So 6 and 7 are special right triangles. So in a 30, 60, 90 triangle is what we have here. 30, 60, 90. Remember, across from our 30 is going to be our x. Across from 60 is x square root 3. And our hypotenuse is 2 times x. So here it doesn't give us what's across from 30. So we have to find it. Across from 60 is 39. But 39 is our x square root 3. So how do I find what just x is? Logan. Awesome. Divide by square root 3. So just x is going to be 39 divided by square root 3. Can I leave my answer like this?
No, you have to rationalize.
I have to rationalize. So multiply the top and the bottom by square root 3. So x is equal to 39 square root 3 over 3. Can I simplify this any more?
Yes.
How many times is 3 going to 39? So 13 square root 3 is going to be my x. And then how do I find r, the hypotenuse?
Wait. I don't get how, cause isn't x just supposed to be x and not square root of 3? Like, isn't the 60 like down the bottom supposed to be?
So 39 is technically x square root 3.
Okay.
So if we multiplied x by square root 3, so that's what we do here in our basic one. What's across from 30 is just our base. If we multiply that times square root 3, that's what gives us 39. So the square root 3's kind of cancel each other out, but it's still in there.
Oh, okay.
It just doesn't look like it's in there because we don't have a square root in that value here.
Okay.
But we're technically multiplying what's across from 30 by square root 3, and that gives us what's across from 60.
Okay.
Now, how do I find r? Multiply what? Multiply what by 2? Multiply x times 2. So our x is 13 square root 3, so I'm multiplying that times 2. And what's 13 square root 3 times 2? 26 square root 3.
So you don't multiply?
All right, so 7, it gives us our hypotenuse here, and we have a 45, 45, 90 triangle. So in our basic 45, 45, 90, our legs are x, and our hypotenuse is x square root 2. Bless you. So our hypotenuse here is x square root 2. So how do I find what just x is? Divide by square root 2. So x is equal to 4 divided by square root 2. Can I leave my answer like this? What do I have to do? Rationalize. So multiply the top and the bottom by square root 2. So x is equal to 4 square root 2 over 2. And can this be simplified anymore? 2 square root 2. So x is 2 square root 2. And what's r? 2 square root 2. The same thing, because our legs here are the same. So 2 square root 2. So a ladder is laying against the side of a 3-story house. A roofer measures the angle of depression from the roof line to the sidewalk to be 58 degrees. The base of the ladder is 65 feet from the base of the house. How long is the ladder? So here we have our house, and our ladder is leaning up against it. The base of the ladder is 65 feet from the base of the house. And what else do we have? Angle of depression. So here, our angle of depression is 58. So that would make this angle down here 58 degrees also. The one up top is 32. And then we are trying to find how long the ladder is. So that would make this x. So which trig function should I use? Sine of what? Sine of 32. If you use sine is opposite over hypotenuse, so it would have to be 32. You could use cosine of 58. You'll get the same answer. So sine of 32 is equal to 65 over x. Multiply both sides by x, so x is equal to 65 over sine of 32. When you put this in the calculator, if you can't put all of this together in one step, make sure you Write down as many decimal places as you can when you do the sine of 32. Because some people only put like 2 decimal places and then their answer was like 7 numbers off, which is too far off. It's okay if you're a couple decimal places off. But if you're putting sine of 32 in your calculator, writing that down, and then dividing that into 62, make sure you write down as many decimal places as you can so your answer is more exact. So here I would put,
Isn't it supposed to be 65?
oh yeah, 65.
Why is that part x and not the
5299. And then when you divide this, you should get 122.66. And what's our unit of measure? Feet. Okay, so I'm going to call this x. How do I find x?
X is
Pythagorean theorem. So 4 squared plus x squared is equal to 38, square root of 38 squared. 16 plus x squared is equal to 38. Subtract 16. So that cancels. X squared is equal to 22. Take the square root. X is equal to square root of 22. Yes.
How do you do that if there's a whole number before the radical?
So let's say we had 4 square root 2 squared, just as an example. Square both the numbers in here. So it should be 4 squared and square root 2 squared. So 4 squared is 16, square root 2 squared is 2. 16 times 2 is 32.
And then the ask, just to multiply that times 2, you only do the whole number?
Right. So if it was 4 square root 2 times 2, this would be 8 square root 2. Okay. So square root 22 is our opposite. So here for sine of theta is opposite over hypotenuse, so square root 22 over square root 38. I have to rationalize, so multiply the top and the bottom by square root 38. What's square root 22 times square root 38? Yes, square root 836. And then over 38. 836 simplifies to square root 209 over 38. And then this simplifies square root 209 over 19. So that's sine. Next, we have cosine. So adjacent over hypotenuse, so 4 over square root 38.
Wait, how did you get the denominator again? The 19?
2 and 38 simplify.
Oh, okay.
So times square root 38 on the top and bottom. This would be 4 root 38 over 38, and then I can divide both of these by 2. So it would be 2 square root 38 over 19. Next, I have tangent. Tangent is opposite over adjacent, so square root 22 over 4. Now for the reciprocal functions, I just need to flip them. So sine goes with cosecant. Don't forget that sine and cosecant go together. They may not be given to you on the test in the right order, or they may not be given to you at all. So just remember, sine and cosecant go together. So cosecant flips sine. This would be 19 over square root 209. Multiply the top and the bottom by square root 209, and you get 19 root 209 over 209. Then we have secant. So secant, I'm going to flip the unreciprocated cosine. So square root 38 over 4. And then cotangent, I'm going to flip tangent. So 4 over square root 22. Rationalize it. Four square root 22 over 22 simplifies as 2 square root 22 over 11. So this simplifies 2 square root 209 over 11. Any questions from number 1? All right, let's do 13. So since it's in radians, the complement adds up to what?
Is that 180 or is it 360?
Complement is 90, which in radians would be pi over 2. Supplement is 180, which would be pi. So we would do pi over 2 minus the angle that's given to us, so 5 pi over 6. In order to subtract fractions, we need a common denominator, so multiply the top and the bottom here by 3. So 3 minus 5 pi would be negative 2 pi over 6. Can my complement be negative? No. So this would be no complement. So now let's find the supplement. Supplement is pi minus 5 pi over 6. So I'm going to make this 6 pi over 6. 6 pi minus 5 pi is pi over 6. I'll do an example of the unit circle here. So negative, we have negative 2 pi over 3. So if I find the positive 2 pi over 3, that would be here. And in the positive direction, I'm moving 1, 2, 3, 4, 5 dots around the unit circle. If I go in the opposite direction, so going negative, I'm going 1, 2, 3, 4, 5, which would be this one.
And then for like 17, like you have to convert it to, like if you can't find it on the unit circle, you have to convert it to degrees and find it.
Well,
That's what I did.
find the coterminal angle because that has the same ending spot. So if I subtract 2 pi, that would be 5 pi. Still not on the unit circle, so subtract 2 pi again. That would be 3 pi. Still not on the unit circle, subtract 2 pi again, so that would be pi. So 7 pi and pi are coterminal, so they have the same ending. So that would be pi, which would be here.
But like what I did was that I multiplied 7 pi times 180 over pi, and then I got 1,260, and then I did 3 rotations.
Right. Which is essentially what you're doing with 7 pi, but like one rotation is 2 pi, then go around another 2 pi, so now you're at 4 pi, 6 pi, and then you have 5 pi, or 1 pi more. So it's the same thing. If it helps you to see it better in degrees, just convert it to degrees and then find it.
But like if we had them like down this, that's what you probably will. But like if we had to like.
So looking at 18. It says find the linear speed of the second hand of a clock given the info below. So our linear speed formula is s over t. So where s is arc length. What's the arc length formula? What's s equal to? R times theta. So r times theta over t. So here it gives us r. When we have half a revolution, what is theta when we have half a revolution? Pi. And then how many seconds is in half a revolution? 30 seconds. And then we just plug these 3 things into our formula. So it would be 30 times pi over, it would be r times pi, which r is 1.72 times pi over 30. And then we plug this into our calculator. 0.180. And then what would our units be? Centimeters per second.
Why is it centimeters?
Because this is centimeters, so the top's measured in centimeters, and then seconds is on the bottom. So 22 says, given theta is equal to pi over 2, and the arc length is 12, find the radius. So our arc length is 12. Our arc length formula is s is equal to r times theta. So 12 is equal to r times theta, which is pi over 2. Remember, in this formula, theta is always in what?
The radian.
Radians. So theta's already in radians, so we're good there. We don't need to do anything to it. Now I just need to solve for r. So I can multiply both sides by 2 to get that to cancel. So I have 24 is equal to r times pi, and then divide both sides by pi. So r is equal to 24 divided by pi, and then I can put that into the calculator and get 7.64. So 21 says, given the arc length is 18 yards and the radius is 5 yards, find theta in degrees. So again, our formula is S is equal to R times theta. It gave us our arc length here, which is S, so that's 18, and our radius is 5. So I have 18 is equal to 5 times theta. I need to divide both sides by 5. So theta is equal to 18 over 5. I could leave it or change it to a decimal, so just divide would be 3.6. But this is in radians, because our formula, theta, is always in radians. So 3.6 radians, I have to convert it to degrees, because my question is asking it in degrees.
Wouldn't radians have like a pi?
It doesn't have to. So radians doesn't always have to have pi in it.
Okay.
So this is 3.6 radians. How do I convert radians to degrees?
Multiply by 180 over pi.
Multiply by 180 over pi. So 3.6 times 180 divided by pi would be 206.37 degrees. So don't forget your little degree symbol when talking about degrees.
So if it's said in radians, then the answer is just 3.6?
Yep, if it said in radians, this would be your answer. So this question was similar to the one on the quiz where it said in radians, so this would have been your answer here, and you don't have to change anything to it.
Okay.
All right, so looking at number 19, we have to find the linear speed of the seconds hand of the clock given the info.
Wait, is this the review, right?
Yes. So this is our radius. To find the linear speed, our formula is S over T. And what's the formula for S?
S equals R.
R times theta. So R times theta over time. So our radius is 9.48 centimeters. When we have a 3/4 revolution, what is theta? 3 pi over 2. And then what's time? 45 seconds. So I'm going to plug those three things in. So we have 9.48 times theta, which is 3 pi over 2, divided by 45. And then you can just put all of this into your calculator.
Wait, that's it?
And you should get 0.99. And then what would our units be? Centimeters per second.
You have to actually like multiply.
So for 20, same formula, R theta over T. Here we have a quarter revolution. So what's theta when we have a quarter revolution?
Pi over 2.
Pi over 2, and what is time? 15 seconds. So my radius is 5.69, so 5.69 times pi divided by 2 over 15. Because it's 15 seconds, because it's a quarter revolution. So this should be 0.60 centimeters per second. So number 7 says, brothers Bob and Tom Katz buy a tent that has a center pole of 6.25 feet high. If the sides of the tent are supposed to make a 50-degree angle with the ground, how wide is the tent? So this is our tent. The center pole is 6.25 feet high. And then the tent makes a 50-degree angle with the ground. A lot of mistakes that people made on the last quiz is when putting their angle. If it says with the ground, that's going to be an angle of elevation because it's from the ground up. So a lot of people, even though it said a 50-degree angle with the ground, they brought it from the top. So this one, I mean, you can kind of see why it wouldn't be from the top, but just that was a common mistake on the quiz, so just pointing it out so you don't make the same mistake again. So if it says from the ground, it's got to come from the ground. And then this is our right angle, so we have our right triangle here. It's asking for how wide the tent is, so that would be this whole length here. I'm going to call that y. But just in our right triangle, we can find what the base is here, which is x. And then how could I find what y is once I find x? Multiply it by 2. So our right triangle trig, we have to work with right triangles. So I have this black right triangle here. I can find x, and then I just multiply it times 2 to find how wide the tent is. So using 50 as my theta, which trig function do I have to use? Tangent. So tangent of 50 is equal to what? 6.25 over x. So when x is on the bottom, you have to multiply both sides by x, and then I'm going to divide both sides by tangent of 50, so I get x is equal to 6.25 divided by tangent of 50. When dividing, in my calculator, just because I lost my calculator, so I use the phone one, I can't do this all in one step, so I have to do it in 2 parts. So I'll find the tangent of 50 first, but when you're doing it in 2 steps and you can't leave it all in the calculator together, make sure you write down as many decimal places as possible. I mean, you don't have to do like 20 of them, but I would at least do like 6 to have your answer exact as possible. Some people on the quiz only put 2 when writing down the tangent of 50, so their answer was like 5 numbers off, which I took points off for that. So make sure you write down as many decimals as possible so your answer is exact as possible. So when taking the tangent of 50, I had 1.1917535. And then just divide. So x is equal to 5.244. And then we said to find the whole width of the tent, I just have to multiply that times 2. So that would give me 10.49, what unit? Feet. So that's my answer. So Ophelia Payne is walking to her office building, which she knows is 150 feet high. The angle to the top of the building from her current location is 6 degrees. How much further does she need to walk? So here is our triangle. She's 150 feet high. This is 6 degrees. That x was here.
Yeah.
Because she's walking this way.
That's why I solved for both, because I didn't know which one I was solving for.
But Miss Meadows sent me the review after I sent it to her, and she said the x was down here. But then why would it tell you that it's 150 feet high if you're just walking like straight across, was my logic of it.
I put X on the bottom because, I don't know, the way I envisioned it is, like, if she's walking, I envision it like she's looking up at it, like there's the building 150 feet, but she's walking towards it.
That would make sense. We can solve for both of them.
It seems like unless they say up the stairs or up something, it's always going to be like straight. Not the hypotenuse.
Yeah. We'll solve for both. I'll call the hypotenuse x and then the base of the triangle y. So solving for y, which trig function would I use? Tangent. So tangent of 6 is equal to 150 over y. So y is going to be equal to 150 over tangent of 6. So what do we get for y? 1,427.15 feet. And then if we were solving for x, which trig function would I have to use?
Cosine? No, opposite over hypotenuse?
Opposite over hypotenuse is sine.
Oh, it's sine.
So is that where you went wrong? Did you? Okay.
Oh, wait. I still did that wrong.
Okay, so sine of 6 is equal to 150 over x. So x is equal to 150 divided by sine of 6. What do we get when we put this into the calculator? 1,435.02 feet. So for number 10, we did this one in class to review for the quiz, but I'll do it again.
Yeah, I wasn't in class that day.
Gotcha. A 5-foot tall bird watcher is standing 50 feet from the base of a large tree. So a 5-foot tall bird watcher here and a large tree here. The person measures the angle of elevation to a bird on the top of the tree as 71.5. How tall is the tree? So I'm looking for the height of the tree, which is x. My bird watcher is standing 50 feet from the base of the tree, so this is 50, and my bird watcher is 5 feet tall. So he's measuring the angle of elevation, which is from the horizontal line up, as 71 degrees.
Wait, why is it?
Because it's from his eyesight up is our angle of elevation.
And you can't solve it from the bottom up and then subtract 5?
No. So our base of the triangle here is 50 because it's just the same as the base from the person to the tree. And then we're looking for x, which is the height of the whole tree. But if I'm just doing the right triangle here, I'm going to call the right side of the right triangle y and find that first. So which trig function do I have to use? Tangent. So tangent of 71.5 is equal to y over 50. I get y is equal to 149.43. And then I just want to multiply that times 2 to find x. Or no, not times 2. I'm adding 5 because this is 5. So I would add 5 to this.
I did the same math and I got the same y value, but I subtracted 5 because I thought that.
All right, and let's do the challenge. So at a point 200 feet from the base of a building, so I have a building and 200 feet here. The angle of elevation to the bottom of a smokestack is 35 degrees. So I'm going to say the smokestack is right here. So this is the smokestack. And this is 35 degrees. The angle of elevation to the top is 53 degrees. Find the height of the smokestack. So to the top of the smokestack would be 53. So this whole angle here, 53 degrees. And I have to find the height of the smokestack. So just this little piece I'll call x. So in my blue triangle, I can find what the height of the building is here. I'll call that y. Bless you.
So the whole thing is y?
No, just the blue part here. The height of the building, not including the
Just the
smokestack.
bottom of the smokestack. Okay.
So to the bottom of the smokestack would be y. So I'm going to use tangent of 35 is equal to y over 200. So y is equal to 200 times tangent of 35. So y is going to be equal to 140.04. And then next I can look at the whole triangle here. So again, I'm going to take tangent, but here I'm going to find the whole length here. So I'll call this z. So tangent, what's my theta here? What angle am I looking at for the whole triangle? 53 is equal to z over 200. So I get z is equal to 265.41. And then to find just the smokestack, I would take the whole thing z and subtract y from it. And that would give me x. So if I did 265.41 minus 140.04, that gives me 125.37 feet.